My name is Joe Gregorio. You can follow me at Bitworking at Twitter. Down at the bottom is the bit.ly link for this presentation. You may actually want to follow that along. In the presentation, I'll come to some pages where you can actually follow some links through and actually play around with some of the code that I'm presenting. So, all right, caveats. I am employed by Google, and this talk does not represent the opinion of Google at all. Code is for exhibition purposes only. I know how to write code better than what's actually there. I took a lot of comments and error checking and stuff out for, getting it to fit on the screen. And apologies in advance for anybody expecting magic or cleverness. This is not what this is about. This is really simple, basic stuff, but it's about making the point that you can get really far with basic, simple stuff. So, a little background about me, so kind of you know where I'm coming from with this stuff, and also I get to point out some other open source stuff I work on. So, I'm employed by Google, and I work on Skia. Skia is an open source 2D graphics library. Has different various backends, CPU, GPU, PDF backends. We're used in a couple places you might have heard of. So used in Chrome, Firefox. We're the drawing backend for Firefox in some cases, not all. Flutter.io, Sublime Text 3, and various other projects. The nice part about being open source is you just never quite know who's going to use you until you get bug reports. Inside the Skia library, there's some things that a lot of people don't know about. Know about. Some of those things are path-ops. There's a link there to those presentations, and SKNX. Path-ops is interesting because it's path operations as it is, but it's on Connix. And if you know anything about path operations, you'll know how impressive that is. And SKNX is basically an interesting way of doing SIMD, but calling it from templates, so you can just do high-level work in C++. So nothing I'm going to talk about today, but those are interesting things that, if you're interested. And again, all open source. My role in Skia is, my team is the infrastructure team. So we're responsible for keeping all the infrastructure up and running all the tests. You can imagine that a library that's used in all of those platforms, right? We have to have a lot of testing. We have to make sure it runs correctly and it runs quickly. And we have to make sure the library compiles and runs on Mac, Windows, Linux, Android, all different GPUs on all of those different systems. So, and then we generate a lot of data from that. So on every commit, we do what are called correctness tests, right? It's a drawing library. You have to make sure it still draws the same or draws reasonably close to the same. On every commit, we actually end up rendering 500,000 images. And we actually end up generating 260,000 individual performance metrics. And then we have to make sure, all right, was that good or bad? Did we slow down? Did we draw incorrectly? So my team builds not only the tools to run all those tests, but then builds the analysis tools on top of that to make sure the engineers can dig through that data. So, and that's where this comes in. So we end up building those tools. Backends are in Go, front ends are in Polymer. We deploy everything on Google Compute Engine, and everything we do is open source. So if you see something you like, that's where to go get it. So these are just some of the UIs that we built. This is actually a mixture of Polymer and D3. If you actually need to put a lot of data on a screen at one time, D3 is really good for that, particularly analysis stuff like this. So that's what you're seeing. This is part of the interface for going through those 500,000 images. Here's the UI and some of the pieces for digging through those 260,000 performance metrics. We also have fiddle.skia.org, which allows you to actually go in and type C++ code into a browser, compile it, run it, and see the Skia images it generates. We're at Google, so we do things at scale, right? So we also have a corpus of 1 million web pages that we can run stuff over, and we have a corpus now of 1 million PDFs that we can run over and test to make sure things still work. This is the user interface for that. And here's the dashboards for making sure everything is still up and running. So Not that any of that is terribly important, but it just gives you the context of what I'm building on a daily basis, and this kind of drives the way I think about things. We need to build things fast. We need to iterate quickly. We need to maintain that robustly. It's not a huge team. And then we need to do things at scale. Just for context, not like, because at scale, working at Google, that means a different thing, right? So my team, we're 6 people total. We have about 4,000 or 5,000 cores that we do all of this work on. Just realize that Google, that's laughably small. So just so you know, we're a very small team. So 2 years ago, almost exactly, I wrote a blog post called Stop Writing JavaScript Frameworks. Obviously a slightly hyperbolic title. So things I didn't say in there with that is I didn't say stop innovating on the web. I didn't say stop using JavaScript libraries. And this is the important part of what I'm going to get to, is a distinction between library and framework. I didn't say to stop using tools at all, and I didn't say I had all the answers. So, and really, it doesn't matter if people continue to write JavaScript frameworks. I'm more interested in people stopping using them. So a better title would have been Start Writing Reusable Orthogonally Composable Units of HTML, CSS, and JavaScript, but nobody's going to click on that. So stop using JavaScript frameworks. In order to go a little further, I need to distinguish what I mean by a framework. So as you write code, right, you start off with little bits of code, right, something along the size of a gist, right, 5 or 10 lines here, hey, this is how you do something, this is a function, right? And then you get a little bigger, and you start to build up a library. If you use the JavaScript, like the underscore library, right? It's got a bunch of functions, they do some useful stuff. Then you get, though, up to a framework. That's where you start getting in trouble. Because my definition of framework is that a framework is something that tries to abstract away the underlying platform from you and possibly even give it a different model, right? That's what I mean by framework. Part of it is that nowadays, anybody publishes anything, they decide they have to label it a framework. I've seen like somebody publish a CSS file and call it a CSS framework. Words have meaning, okay? So framework in this meaning is abstracts away or possibly even changes the model of the underlying platform. So what is that platform? When I'm talking about web development, that's HTML, CSS, and JavaScript. Those are the core technologies available in the browser. They're incredibly powerful. This is what I mean by a framework. React. Virtual DOM says right there, React abstracts away the DOM from you. Don't do that. That's a framework. GWT, Google Web Toolkit, right? Abstracts away everything from you, okay? There was a time for frameworks, okay? For an old timer in this industry, you know at one time the idea of abstracting away the operation of the browser was necessary. Do you remember the IE box model? Okay, this is the IE box model, okay? They had a different padding and margin model than all other browsers. If you have a slight twitch under your left eye, you know what I mean. This would drive you nuts, okay? Do you remember the IE event model? Again, totally different from all other browsers, right? Let's not just pick on IE, though. Do you remember the Netscape layer tag? Yeah, that was a thing, okay? So there was a point in time where there wasn't a consistent model underneath to apply. And so, yeah, you would abstract away because you needed to get some commonalities. You don't need that these days. Browsers have caught up. They are mostly conformant to the standards. When I first started working on the browser, I never thought I would see this green all the way across, right? And that's just SVG basic support. So it is, where it was to where it is today is fantastic. Okay, so there was this historical need for frameworks. Now, one of those needs, which is this model of the browser not being consistent has gone away. And you can fill in the rest with polyfills, right? So if the way that browsers differ from each other is small enough that the rest can be polyfilled, right? You can bring in simple libraries. They basically monkey patch in the functionality you need if it's not there, and then you're good. So we have frameworks. Polyfills now fill in the potholes along the road for you, so that kind of weakens the need for a framework. But what about all the other benefits? Frameworks are still libraries, right? They still abstract things away from you. And those abstractions are leaky. You can't have a non-leaky abstraction of an underlying platform. For example, this is a bit of an old Stack Overflow question, but it's completely typical of what I'm talking about, right? Abstractions leak, right? And the question here is it possible for GWT to give the stack trace of the original Java code that I wrote my GWT app in after a crash as opposed to the JS stack trace, right? They leak. Abstractions are abstract. When you use a framework, you're still having to learn something. You still have to learn that framework. And if it breaks, you got to figure out what broke and what it is. So it's a huge amount of something. You still have to learn something, right? It's not saying you're learning nothing. And then a couple of the other arguments I've heard are, well, you get great reuse out of that framework. I was going to have lots of slides on this, but I'm busy porting my Dojo widgets to Backbone. Or a little closer to home. Yeah, I heard those groans. So we know, it's too easy to take pot shots at frameworks at this point. It's like shooting fish in a barrel, one giant fish in a barrel. I asked my daughter to draw this for me. She's like, you want me to draw what? But there is a need still that a framework could fulfill, and that is code organization, right? I'm going to start putting together an app. A framework gives me a structure upon which I can start building my app. My contention is that web components fills that gap, and that you don't need to use frameworks. You should be using web components. So what do I mean by web components? Web components is a group of technologies that have come around in recent years: HTML templates, HTML imports, custom elements, and Shadow DOM. I am not going to cover Shadow DOM today. So everything I'm going to talk about today is just those first three. So we're not even going to use that. HTML templates, all right? They are now part of the HTML spec, very widely implemented already, so you don't even need a polyfill in most cases. What are they? Template tag. You just put a template tag in, and then you put stuff in it, any sort of markup you want in between those. The stuff that's in there is parsed by the browser, so it's going to be parsed quickly. The content is not rendered, so it's invisible to the user. The content is hidden, so you can't even search for it. And it's inert. If you put JavaScript in there, it doesn't run. Right? So it's basically freeze-dried code in there, but it's already parsed by the browser. How do you go about using that? Well, here we've got a template. Inside there, that template is a div. And then I've got some JavaScript that shows how you would manipulate this. Right? So there's my template. I do document query selector to find that template tag, and then I call .content on it. That basically unfreeze-dries the thing that's in it. And then at that point, I can take that and shove that into the document. Import that as a node, and then append that node into my document, into the body. This is where those links come in handy. So bit.ly/zf-template. Follow those links. All of this code is available for you to play with on Plinker. So that demonstrates all of these things. So that's HTML templates. HTML imports. So if you write JavaScript, you can put JavaScript in a separate file and put a script tag with a source and import it in, right? You can break it apart. You can do the same thing with CSS. Why can't you do the same thing with HTML? right? It's just kind of insane that that capability doesn't even exist. What you would think as a browser, that would be like the first thing you would have. It doesn't exist. It does now, HTML imports. You put a link, type of rel is import, and the href is just the link to it. Oddly enough, this was slightly contentious. I think it's moving forward. I mean, as far as the spec is, I think Firefox was, or Mozilla was possibly against it. I'm not sure where that is. This is about a year ago. But they're absolutely amazing. You can polyfill it in. And it's absolutely brilliant for organizing code. In, for example, keeping HTML, CSS, and JavaScript together, which is actually very important in the next thing we're going to talk about, which is custom elements. So with HTML imports, the links are dedoped, so you never load it up more than once if you have multiple references. It can contain anything an HTML file can, so HTML, CSS, and JavaScript. And the important point here, as we're going to see in a little bit, scripts are executed in the context of the window that imports them. So if it's an HTML import, you think there's going to be a DOM document with that, but there's also the place you imported it from. And you have to keep those two in mind as you go forward. So we'll see that. So let's look at an HTML import. Our file, import.html. Let's put in an HTML template, because we just learned about those. Those are cool. And here's some JavaScript. Now, the little bit of trickiness, which is totally different from what we saw before, is remember, the script runs in the context of the window that imported it, but I need to reach back into that import.html to get to the DOM, to manipulate stuff. And the way you get there is .current script. That gives me the script, and then you say the owner document of that script. Now that's obviously the import, where it was. Everything else from that point just runs the same. Find your template, call .content on it, document import it, and then boom, slam that into there. And so how do you go then about using this code? I import webcomponents.js. In this case, this is the polyfill for these technologies I'm talking about. You can see it yourself at webcomponents.org. So I import my polyfill. And actually, in this case, we're just using webcomponents.lite.js, because we're not using Shadow DOM in any of this, and so we don't have to polyfill Shadow DOM. So we get to use a smaller polyfill. And then we import our .html. And if you click on that link and run it, you will see exactly what happens. That runs, that div gets imported into the page. So let's start wrapping up some of the code that we've been talking about so far into a little bit of a library, not a framework, library. So we'll have a context object that we'll create so that when it's instantiated, you notice it grabs the context of where it's at, where it's being run from. And then we can just have an import function to say, look inside that HTML document, pull up the thing with the ID, and instantiate it. Take it out of the freeze dry state. So if we now go back and use our simplify our JavaScript this way, we have this new context. Oops, I thought I highlighted it. So we just created a new context, and we say document body append child, and then we context import that thing. So much simpler. So that brings us to our third thing, which is custom elements. Oddly uncontentious, given the amazing power that it has. And in this case, we're only talking about creating new elements, not subclassing existing elements. So how do you do this? This is the API for it. You create an object that is based on the HTML element prototype, which makes sense. We're creating HTML elements. We then have a series of callbacks that represent the life cycle of an element, things you might want to know. So let's jump forward. Current for life cycle element callbacks: created, attached, detached, and attribute changed. So if you're creating an element, those are the kind of things you would want to know. So in this case, we are just saying, all right, when we're created, as a child of mine, change the content to hello world. You can also add whatever other functions you want on that DOM element. And then here it is. You document register. You've registered your new element. you give it the tag name, and then you give it the prototype for what that DOM JavaScript object is going to be. And that's it. And that's how you use it, right? I now have a hello element tag I can put in. And when that gets rendered on the page, the JavaScript's going to run and go, oh, yeah, you've been created, and it'll stuff hello world inside there. And that hello world will get rendered on the screen. So these are cool functionalities. So let's wrap up that whole idea of creating a new element with the name and the prototype and put that in our util.js. So we're up to 13 lines of code. We're not anywhere near even probably the library length, never mind framework. So, and now this is what our call, all that previous code that we just wrote, now simplifies to this. We have a created callback and our add more text function, and we call that inside of our new element where we register it. Follow that link, you can see that running. So that just gives us hello world. So we have all of these new capabilities. Let's put them together in kind of a motivating example. So common piece of functionality actually we find, particularly with the stuff we're doing with putting a lot of data on the screen, we currently want to toggle stuff on and off, right? Show me the details or not. So that's what this is going to be. This is just going to be an element that says, you know, hide or show the thing below it, next thing in line. So this is what that code looks like. We have our template, which is just a button. Remember, that's our freeze-dried code. There's our context, so we can grab our state, because we're going to use this inside an HTML import. And then we create our toggle next element. What does that do? When it's created, it, first of all, grabs that button and stuffs it into the body. So that's now visible to the user as a child. And then we add a callback, listening for click. What happens when we click? Well, that's down here on button click. We say, all right, find the next element sibling, i.e. the next thing in the DOM, and based on what it is it collapsed or not? We then change the visibility of it, and when we toggle the button back and forth between hide and show. So how do you use it? Let's back up. We import our web components light.js, we import our util.js, and then we import our HTML import, which has all that code in it. And now we have a toggle next element that we can use. It looks at the next thing in the DOM, doesn't care what it is, presents a button which says hide or show. I click on it, and it just appears and disappears. So that appears and disappears. Let me, oops. Yeah, I knew I was messing with the, where am I? Demo gods are not smiling on me now. All right, the wrong way. Yeah, all right, I was gonna click on you and show that. You can click through and see that. All right. Yeah, I'm not even gonna click on that. All right, so you can follow through and see that. I am not gonna mock the demo gods. All right, how did this work? How did this bit of functionality work? It worked by adjacency in the DOM tree, right? I got this bit of functionality by saying, look at the next thing, look at the next element sibling, and act on that thing. These are the surfaces that I'm talking about that you can use for code organization. Use the surfaces already present in the browser. Those are DOM attributes, DOM events, and just the basic structure of the DOM in the page. Right? If you could start creating custom elements, you can inject yourself in there. Right? So if I have a button, right, I could have attributes on those. I can then look for things that have that ID. Right? I can click on those things. Events. I can actually add event listeners. I can listen for events coming out of DOM elements, and I can actually create custom events coming out of the elements I create. DOM structure. I can use the parent-child relationship between elements, and I can use all the other things that are built into the browser, CSS selectors, right? I could do query selector.foo, and I'm going to get the first 3 paragraphs out of there, and not the last one, right? There's a lot of power built into these primitives in the browser. So let's do a little more detailed example. US cities, right? I want to build something that does some sorting, all right? So I want to have a UI that looks like this, and I want buttons, sort on population, sort on density, sort on percent change, and I've got the 5 most populous cities up there. This is what I want it to look like in markup, right? I have this sort stuff element, and inside of it, it is going to have buttons. And each of that button is going to have a data attribute that's going to tell it, oh, what are you going to sort on? So the first one says data key pop. Next one's data key density. Third one is data key change. So that means look into the next DOM element that you see. Actually, in this case, there's the data target sortable. So it doesn't even have to be adjacent. We can now say, oh, pick up this thing based on its ID in the DOM. And now come down here into the sortable stuff, and the values are there also as data attributes. So data pop, 8.4, 3.9, 2.7, all the way down. So when I hit that first button, data key pop, it's going to look down into sortable, look, and then sort all of those elements based on the values it finds there. So how am I going to do that? Create an element called sort stuff. There's my created callback. And what I want to do is I just want to listen for clicks, right? That's all I want to do is listen for those click handlers. What happens when a click happens is this. So there's our click handler. We find our target that we're looking for. We look at the dataset key, right? Making sure we've got that key value that we're looking for, right? In this case, we're looking at, if we're on the first button, it's pop that we're looking for. We look at our target. We grab all of the elements that are children of there, and then we sort them based on those dataset values. All right? And if you click through the link, ZF sort stuff, you will see you can click on those buttons, and the order of those elements will change as you click and select. And it uses that sort of DOM. So let's look at a lot of the things that we used in here. What are the surfaces? Sort stuff has a data target attribute that selects the element to sort on, right? We're using their attributes and DOM structure. The target children have data attributes that the elements are sorted on. Again, we're using DOM structure and attributes there. Sort stuff registers for a click. That's an event. From its children, DOM structure. And sort stuff children have data attributes that determine how the target children will be sorted. So these are our surfaces. These are the ways we're putting these things together, right? And because we're only using these surfaces, we get a lot more flexibility out of the system, right? Sort stuff doesn't care what the children are. Nowhere in there does it say, I'm looking for a button, right? I'm looking for something that generates a click. That's it. Sort stuff doesn't care what the elements found at data target are, right? All they have to do is have these data key attributes. The things that are sorted only have to have those other data set attributes on them. I could sort images. I could sort other buttons, right? It does not matter. I could change the children of sort stuff, and it still works. I could change the sort stuff data target. So same exact thing. There's sort stuff, but now I've got radio buttons, and the thing I'm sorting are rows in a table, right? No change in the code that I wrote. This is that kind of plug-and-play functionality you want when you build things, right? That's what it looks like now. Those are those radio buttons, and there's the sorting. And you see ZF sort stuff too. You can click through and play around with that. Let's roll in toggle next. We already created that element, right? So I can put hide buttons in there. You can imagine what the markup looks like for that, and that just works straight out of the box. So that's the thrust of this, right? Use web components. For packaging, package things up in HTML imports, and for organization of your code, build up elements and stitch things together using events, attributes, and the DOM structure. So now you can see why the title of my talk should have been Start Writing Reusable Orthogonally Composable Units of HTML, CSS, and JavaScript. And now maybe if you see that title, you'll click through. All right. Questions I have had previously are data binding, right? Some people use a framework and data binding isn't there, which is cool. It isn't necessary. You don't have to abstract away the DOM or JavaScript or CSS in order to get data binding. It should just be a library. Here, you can click through bit.ly, and that is data binding. Actually, it's just data templating. It's in 100 lines of JavaScript. It doesn't actually fit on the screen. You can't read it if I brought it up. You can click through. It's 100 lines of JavaScript. This is the type of manipulations it can do. It can do path rendering, right? foo.bar.baz gets replaced as you go through this is going through a series of objects. It can actually do enumerations over things in arrays. It can actually do looping over key value pairs in objects. It's 100 lines of JavaScript. It doesn't need to be a framework. How do you use it? Right? You can just take your DOM with an HTML import, take it out of the freeze-dried state, pass it into the expand function along with your data. That gives you DOM. Stick that back in to your body. So here I'm saying things are capable, right? This is a capable platform. You can use these tools and build things with it with a lot of power and functionality. But it turns out when you start building these things, you actually realize you get even more benefits than from using a framework, right? There's more things that I didn't think about initially. One is because you're just using the DOM, you're just using native capabilities, it's much easier to mix and match stuff. So with a lot of those UIs I showed you, a lot of those huge data displays, we actually build using D3.js because it's very fast. It is built for doing that sort of data manipulation. And we can do it. There is absolutely no problem with mixing and matching what we do with D3.js. It's just HTML. The other part is, in a lot of cases, it's better than native. Okay, if you've done any web development, have you ever tried to style a checkbox or a radio button? Right? It can be messy, and there's just not enough hooks in there to actually get styling the way you want, and it doesn't really work across browsers. But if you create a checkbox this way, you can actually style it, right? You can actually have those hooks to do the styling. Another case is details and summary, right? I saw this element appear in the HTML spec. I'm like, this is so cool, right? Because you have a summary and a details, and you click on it. The details are always shown. The summary is always shown. Yeah, you click on that. It always comes with a button, and then it expands and it shows you the details about that summary. Kind of similar to the hide button I just showed, but each part can have its own DOM underneath it. You can't use that today, right? Not for you. But if I create a details-x and a summary-x using these techniques, it works everywhere. And I can style it, right? Details and summary actually has the same styling issues, even more so, than styling a checkbox or a radio box, right? Because it's a new element, and so, yeah, it's hard to style. Not everything is puppies and roses over on this side. So there are missing pieces. I didn't cover Shadow DOM. Shadow DOM is a way of hiding things from users. And in this case, you can't style down into the Shadow DOM when you start creating stuff. And so that's where CSS variables comes along. That's another spec that's up and coming. And for a lot of this stuff, you actually want really good compilers because you actually want to essentially scoop up all your HTML imports and concatenate them together and reduce duplicate code. Better tooling just in general for web development as actually a need, not just here. So it's across the board. So CSS variables are actually coming along quite well too. As you can see, the support for them is getting there. So when I wrote this blog post 2 years ago, I was just one lone voice in the woods. yelling to myself. I presented basically this talk or similar talk to this about a year ago, and there was still, just me. But now we're growing. There are literally dozens of us out here who believe this sort of stuff. This is an article on Slack files. You probably don't need a JavaScript framework. So there are other people coming to the same conclusions. So that's about it. Let me see. Appendix. Yeah, so webcomponents.org. Look at the polyfills. You can see those there. Bitworking.org is the manifesto, the rant that launched it all. There has been other people writing similar things out there actually for a while. Vanilla.js, you can look at that. Funny site, but yes, along the same veins. So, and that's it. So we got about 5 minutes. Any questions? So we have microphones.
Given that you work at Google, you have potential access to people that work on frameworks like Angular, Polymer. You guys have open discussion in terms of the benefits and drawbacks?
So actually on my team, we actually do use Polymer. Right. Okay, so repeat the question. So working at Google, do I have access to the Angular folks and the Polymer folks, and can I rant to them? And what I said was, my team actually uses Polymer. Right. Polymer isn't a framework. It is just a library. It sticks to this philosophy of just, you build elements, and that's how you build up your structure. So.
I had a similar question. So we have Angular 1.x app. We have a guy who has built apps in Polymer, and we are having some sessions taking capital1.com into Angular 2. So it seems like similar kind of frameworks are. And I've heard Angular, web components will be integrated into Angular 2 and they will be working seamlessly. So if you have to decide on a technology today, or let's say in a couple of months, should we be going to Angular JS 2 or stick with Polymers? So it's a little confusing. Google is all have the frameworks are coming out of Google. And it's kind of confusing for someone like us who are consuming it.
Yes, we have lots of different opinions in-house about how to do things, and I didn't even cover Clojure and the Clojure compiler. So yeah, there's lots of different technologies that go along. My preference has been Polymer, and we've been successfully building stuff with it for 2 years. And I like it for the reason that, it allows us to keep things orthogonal, and we can bring in things like d3.js when we need it. If you already have an investment in Angular, that's a totally different conversation. So.
You can build components in Polymer, like web components, and that can be integrated into your Angular JS. So both can exist at the same time.
Yes. I thought there was some issues, at least with Angular 1, with incorporating into the DOM lifecycle of custom elements at one point. And I think there was definitely work to address that. And at the very least, my hope here is that if people are working on frameworks, to take those things into consideration, right? That people may be using custom elements and trying to work with them. It seems like a little progress.
Thank you.
So my question is, with framework, it's not about manipulating the DOM, right? So we use framework to structure and how to architect our application, how the component communicate together. Also, we can use dependency injection and all this kind of stuff. So, of course, you can do them without framework, but you have to do a lot of stuff by yourself. With framework, it's a lot more expressive, right? So.
Yes and no, and that was kind of what I was trying to get to was that if you build custom elements and use the surfaces that are already in the browser, as far as events, generating events, custom events, listening to events, using the DOM structure, if you use that, that can be your framework. That can be your organizational structure for how you build your code. And yeah, that's, like I said, at least for my team and for people, using Polymer, that works. It is sufficient.
Yeah, but how components communicate together? That's, for example, that's something React does.
Right, so when the components communicate together, it is those surfaces, right? It's going to be through events. It's going to be through the DOM structure. So, all right, I think that's it. We're at time. Thank you very much.